Have you ever heard of the word adjacent before? It's totally cool if you have not, but have you heard the word adjacent? Some yeses, some nos. What do you think adjacent means? It's cool if we're not sure. Who's got an idea? Adjacent means? Across from? Next to? Is that what you said? Pretty close. I'll draw you a picture. You don't have to draw this, right? Here's a room that I'm going to call the blue room. Please don't draw it. You don't have enough room for all this. Don't draw it. The blue room. Here is a green room. Do those rooms touch each other? Yes or no? Last warning, guys. Are those two rooms touching each other? Yes or no? Cool. Are they overlapping? Nope. Like if I shaded that in green and I shaded that in blue, they never overlapped, right? That is, in our own words, adjacent. They touch each other, but they don't overlap. So check this out. What if I drew like these rooms right here, the red room and the blue room? Are the red room and the blue room touching each other? Do they overlap? The red room is completely inside the blue room. That doesn't work. Those are, guess what the word is for not adjacent? Starts with a non. They're non-adjacent, right? And here's another one. What do you think about this red room and this purple room? Are those adjacent or non-adjacent? They never touch each other. So to be adjacent, they are two angles who share a side. Two angles who share a side and don't overlap. Two angles who share a side and don't overlap. Two angles who share a side and don't overlap. So we'll sketch this picture that you kind of see. And that's an A right here, a B, C, D, and there's a 1 and a 2 in there. While you're sketching that, I'll ask some questions. Who's like the vertex of all those angles that you see right there? The vertex is blue, right? I'm not going to force you to highlight today except for on a couple questions because we kind of forgot to maybe go get highlighters, but I'm going to highlight some stuff. You can darken with a pencil if you wanted to. You don't have to. You can maybe just see what I'm talking about, but check it out. If I highlight this angle right here green and I highlight that angle right there red, do those touch each other? Yes. Do they overlap? Like if I was to shade the first one in red or green and the second one in red, would the shade overlap or do they not overlap? Those are adjacent angles. Cool. Those are adjacent angles. Do you see the green one right here? I want to call him by 3 letters. You told me B is the vertex, so what would be the name of that guy by 3 letters? Angle what? B's got to be where since he's the vertex? B's got to be in the middle. So angle ABD, well, excuse me, yeah, ABC. I said that wrong. I made a mistake. I owned it, right? The green one is angle ABC. Are we cool with that? And what? Name the red one. Use by 3 letters, please, though. You and your table group, name the red one and write it down, right? Write it down. Bless you. How about angle CBD or angle DCB? Is that cool? Either way, right, you can name them as long as B is in the middle. Do they have nicknames, though? Could I have called them by something else? Angle 1, right? Angle 2. But what you can't call them as angle B because isn't there more than one angle with B for the vertex? So cool. Those are adjacent angles right there. What I have, though, is you don't have to draw this. Let me just try something else here. I'm going to draw what's called a counterexample. You might see that on some upcoming homeworks. It's like, what do you mean by a counterexample? I am going to draw this picture right here. I'm going to just go back and maybe like erase a little bit. What if I would have done, I'll just start over. What do you think about this angle right here in blue, boom, and this angle right here in green? Do they touch each other? Yes. Do they overlap? I'm going to shade the blue one in. I'm going to shade the green one in. Did they overlap? See, just because they touch each other doesn't mean that they're adjacent. They can't overlap either. And I know the screen is kind of weird to see and everything, but did you see how I highlighted that one blue one first and then the green one? The shared ray was like right here. That's not where it needs to be. It needs to be like in the middle. That's where they share each other at. So those are non-adjacent. That would be like a counterexample. If they said draw a counterexample, it means draw something that's not adjacent. Here's another one. What do you think about this? This black angle right here and this blue angle right here. Adjacent or non-adjacent? Why are they non-adjacent? Not touching at all, right? You cool with that? So adjacent, they're touching each other, and they don't overlap. Rock on? So how about our next word? Man, I'm all lost on where my slideshow went. I apologize for you guys on this. Complementary angles. Is that the next word? Or did I skip one? Complementary? Complementary. I bet you've heard that word before also. Complementary means two angles that add up to be 90 degrees. Two angles that add up to be 90 degrees. Two angles that add up to be 90 degrees are complementary angles. And the weird part is, that's like harder than people think to do it, because watch this. You don't need to draw it. This doesn't work. That is not complementary angles, because how many angles do you need to be complementary? You need two. I drew one angle that measures 90 degrees. That is not considered complementary. It has to be two. So let's do a little bit of sketching. Like I said, I didn't give you much room. Let's sketch an example, and we're going to start the same like this. So just like with, you can freehand it or whatever, I'm going to sketch a little angle right here, and I'm going to make him look like that. Could you help me? Did I make that look acute, right, or obtuse? Acute, because he's less than 90. I'm going to just pretend he's 30 degrees, right? I didn't actually measure it. I just like put the 30 degrees on the inside. But if I want to draw what's called the complement to that, I have forced my hand. Aren't they supposed to add up to be 90 degrees, right? And the first one's 30. If you need to use a calculator, you can. But the other one has to measure how much? Tell your table. Tell your table. What's the other one have to measure? How much? 60 degrees. I'm going to sketch a bad example. You're learning. You know what I mean? Why is this a bad example of a 60-degree angle, even though I put a 60 on the inside? I made it look obtuse. Shouldn't it still be more acute? Does that make sense? So we'll sketch that. That's a vocab word that's not on your sheet, but they'll mention on some homework and some quizzes. It's called the complement of that guy. When I had a 30, the 60 was the other angle it had to be complementary, so that's called the complement. The complement. Tell your neighbor, what did we draw? Adjacent or non-adjacent complementary angles. What do you think? Non-adjacent. So now, your job, next to it, could you do this? Could you draw adjacent complementary angles? Give it a shot. See what you think. They have to be adjacent complementary. They got to touch each other and not overlap. Can you draw adjacent complementary angles? It's not easy. If you mess up, who cares? We'll fix it. But I'll start like this. I'll draw this little dude right here. You could have something completely different. I'll make him 20 degrees. But could you do the math for me? What does the other angle have to be its complement? 70. Should I make my new angle touch this one or touch this one? Because I said adjacent, right? So it's got to touch. So like, you really wouldn't draw this ray twice, but I drew it anyway. That would be like 70 degrees. That's honestly like the hard way to do that. Did anybody have an easier way to do that? Since they had to add up to be 90 and they had to touch each other? What's that? 45 and 45, I get you on that. I don't care about the two numbers that you chose. Like, what's the overall giant picture got to look like? See that? Not quite a square, but a what? A right angle. What if you started like this? Boom, 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 boom. Isn't that 90 right there? And then you did this. You put a ray inside of there, and I don't even care what they measure. Do those two, are they adjacent, and do they add up to be 90 degrees? So there's a shortcut if you wanted to do it that way. These were what? Adjacent or non-adjacent? And non-adjacent. So very nice. If complementary means there's two angles that add up to be 90, have you heard of the word supplementary before? Two angles that not add up to 90 but add up to be 180 degrees, right? 180 degrees. Two angles that add up to be 180 degrees. Two angles that add up to be 180 degrees. And now I will give you and your table a challenge. Please sketch for me non-adjacent supplementary angles. can you sketch for me non-adjacent, so you decide with the table, is that touch or not touch, you know, non-adjacent supplementary angles. Give it a shot. If you mess up, who cares? We'll fix it. Non-adjacent supplementary angles. So before I sketch, you tell me, I said non-adjacent, touch or no touch? No touch. So I'm going to make this one right here. I better probably put a number in there that's bigger than how much? Bigger than 90, right? Are you with me on that? Why bigger than 90? 110? I don't care. Like, could you use 90 and 90? Would that work? Yep, that's fine. You know what I mean? But it's just like I chose 110. Who's my other number got to be? Let me word that better. Who's the supplement to 110? 70 degrees. What if you can't do it mentally? What would you do in the calculator? 180 minus. What do you think? And now, draw the adjacent supplementary angles. Adjacent supplementary angles. Adjacent supplementary angles. Touch or no touch? Touch. What's wrong with this? They're supposed to add up to be 180. I drew that. I drew a line. Does a line measure 180 degrees? Well, lines go on forever and ever and ever and ever. They totally do. But measure-wise, remember acute was between 0 and 90. Right was 90. Then larger than that is up to, what is this right here? How many degrees is that? Not quite 0. 0 would be this, right? A line measures how many degrees? 180. Is that adjacent supplementary angles? Did I draw adjacent supplementary angles? I need 2. So that doesn't work. What if I did this? Angle 1, angle 2. You get a daily grade for participating. Congruent angles. We talked about congruent last time. It's angles that measure the same amount. Angles that measure the same amount. Angles that measure the same amount are called congruent angles. Congruent means same size, same shape. That's what that is. But congruent angles, since they're angles, we know they're the same shape. They just measure the same amount. I know you have a very small space right there, so let's sketch a little bitty picture. Could you make a picture just like mine right here? I'm going to make this little dude right here, and I'm just going to call him 40 degrees. I know that was really little, hard to see. But just sketch a little 40-degree angle. Let's call him angle A. So since he's the single angle in the picture, yes, you can use A for, or whatever, just call him by one letter, right, that angle A. I want to draw angle B being exactly the same as that, right? So I'm not going to be perfect because we're not really measuring, but can you make something look exactly like that, right? Exactly like it. Like, for not measuring anything, is that pretty stinking close? Does my green angle and my red angle look exactly the same? My question to you is, are those congruent to each other? Congruent angles measure the same amount, right? But there is a way to mark that without putting the 40 degrees in there, and this is where I lose a lot of people, even in advanced geometry. I know this is just geometry, but how to mark them. That'll be the first question on your homework today. Mark these things correctly in the picture. I will help you with that, but let's just learn. To mark angles the same, we will use what's called arc marks. A few days ago, we used tick marks to mark segments the same, but we didn't do a lot of it, so you're not too good at it right yet. We're going to get better at it. But to mark angles the same, we put arc marks in there. So would you please follow my lead? Put this little arc mark right in there. See, it's just like a little swoop inside of there. And isn't angle B exactly the same as it? So it gets the same arc mark. Boom. And now, see how good you are. I'm going to draw a third angle. You do not need to, but I'm going to draw a third angle, angle C, and I have 2 arc marks in it. Is angle A and angle C congruent? This one has one arc mark. This one has two arc marks. Same thing or different? Different. Changing it, boom, is angle A, which now has two arc marks in it, and angle C, which now has two arc marks in it, congruent to each other. Yeah. Then, here's what we'll do. We'll say, I'm going to just erase this. We're going to go back to what we had. Angle A is congruent to angle B. Do you remember the congruent symbol, right? The congruent symbol. You'll see that a lot. The old congruent symbol. So angle A is congruent to angle B. Angle bisector is a ray that cuts an angle into two congruent angles. It is a ray that cuts an angle into two congruent angles. A ray that cuts an angle into two congruent angles. A ray that cuts an angle into two congruent angles. And that's a big word. It's going to come up. Later this year, we're going to start doing proofs. You know, we will need to know all these definitions. So this is why I want you to keep your notes. Definition of bisector will be used a lot. What is a bisector? It's a ray that cuts an angle into two equal pieces. I totally know you don't have enough room to draw this picture, but down below there's 4 problems right there. So just watch mine real quick. Let's say I use my protractor, and I had this angle right here, and it measured 50 degrees. Right? His name is ABC. You don't have to draw this picture. I'm just kind of showing you. What if I wanted to like make another ray that bisects it? First of all, do you feel that that ray should start from B? Take your earbud out. Go to C. Should the ray that bisects it start from B? Yes or no? What do you think? Yes. How many degrees would each one of those bad boys be if the whole thing was 50 to start with? 25 and 25? There's a way for me to not have to write the 25 and 25. Sorry that the fire drill kind of interrupted us right there, but I could put some sort of marks in the picture to know that they were the same. Do you know what those marks are called? Arc marks. Boom and boom, right? Like I said, you didn't have to have that picture, but let's do some problems together. I have some typos on here that I want to fix. First, scratch out the word non. I don't want that to be there, so I want them to be adjacent angles. And I also would like this angle right here to not be angle DFG. Let's scratch him out, and let's make him angle DAC. That's right. It was right on your worksheet. It was wrong on my slideshow. Thank you for correcting me on that, right? So let's see if we can read it, right? So it says, draw adjacent angles. Could you tell your neighbors, what does that mean? Touch or not touch? Cool. And then this says angle BAC. Uh-oh. What does that bad boy mean right there? Congruent. It's a new guy, right? Congruent to angle DAC. Where, uh-oh, what does that M mean again in front of there? The measure of angle BAC equals 40. Here's the problem. That's too much information. That's a lot right there to try to do that all at once. We're not going to use the protractor to measure because I just want to make this go a little faster. We're going to do this. Can we start by just like making a picture of this just with a straight edge? We are going to use a straight edge, but can we draw angle BAC and it measures like 40 degrees. Help, who's the vertex? A. So we're just going to use a straight edge. You don't have to use the protractor, but let's start with this. Roughly estimate it being 40 degrees. Like you don't have to truly measure it with the protractor. We're just going to call him angle BAC, and I'm going to put 40 degrees inside of there. Angle BAC, 40 degrees. Then talk to a neighbor about what this means. Like, I have angle BAC being 40. Now I need this, right? I need angle DAC to be congruent to it. What does that even mean? Discuss. What does that even mean? Same size, same shape. They're both angles, right? You know, so the first one measures 40 degrees. What should the new one measure? 40 degrees. But here's the real problem. What's the name of our new guy? D what? AC. Is there an A in my picture already and a C in my picture already? So you can't, like, draw new ones, right? If there's already an A, there's already C, it's got to be there. So let's branch off and see if we can put a D in the picture. Like, it's got to be on another ray, and it's got to measure 40 degrees. So give it a shot. If you're not sure, take a wild guess. We can erase. Angle DAC has to be in this picture as well, and it's also got to be 40 degrees. I've got an A and I've got a C, and this would kind of be not the best, right? It's not horrible, but if I put it there, there's no way that angle DAC, if I highlight this guy right here, can be 40 when the one inside of it already is 40. Are you with me on that? So that doesn't quite work. Wouldn't that dude, that new ray, have to kind of go down this way in that case? Does that make sense? Put a D on that puppy? That's weird. And that's got to be 40 degrees. I would like you to do what the homework is about to ask you to do here in a few minutes. Also, mark this correctly. Are these the same? Yes or no? And they are angles. How do we mark angles the same? Tick marks or arc marks? Arc marks. So boom, boom. Let me show you something that people were just about to ask. I've done this for a long time. Watch me do this. This is not wrong. I don't like it. I hate that. I hate that. Does that look like one arc mark or two different arc marks? One. So I'd like it. We'll just ignore that bell. I'd like it if you put a little arc mark in there and then stagger it to where they're separated, you know? So all that. Cool. Let's try the next one. Draw the measure of angle BAC equaling 110 degrees with an angle bisector, something that I can't quite see, AE, right? So we won't need to measure it. Let's just do this. Let's just start with a ray, boom. And when I don't measure it, but I still do it, what kind of angle should 110 be? Should it be right, acute, or obtuse? Obtuse. So we're just going to, I'll tell you what, let's do measure this one. This one's easy to do with our protractor. Put the whole of your protractor right on top of here, and your black arrow on top of this guy. Right? The whole of your protractor goes here, and the black arrow goes there. And we'll go to 110 and put a tick mark. Help your neighbor. Some of us were gone last time when we showed you how to do this, so help your neighbor if they need help. We'll go to 110, and we'll call him angle BAC. I will help you too in a moment if you need help. But we're supposed to have like ray AE bisect this guy. If the whole thing's 110, and I want to cut it into two equal pieces, what's my new little angle's got to measure? How would you get that if you weren't quite sure? Take the 110 and do what? Divide by 2. So then we got to start all over. Put the whole of your protractor back on here, and black arrow on top of that guy, and go to 55. That's not the ray. And they wanted that to be called ray AE, so I'll put my E right there. I didn't measure mine because it's hard to put my geometry. It should look better. You need to measure it to 55 degrees, so yours will look a lot better than mine. But then I'm going to try something and see if you think this is a good idea or a bad idea. What if I put the 110 right there? Does that look like a good idea or a bad idea? Yeah, it's not good. So there's a couple ways to do it better. One, you could put the 55 degrees and the 55 degrees. That is awesome. I love that. That's one way, right? The other way is if you didn't have that, you'll need to learn to read some pictures anyway. You might need the whole thing being 110, so you put like that big green swoop that I put up there, showing that you did 110. Is there a way for me to know that both of these are 55 without actually like putting 55, knowing the whole thing's 110? How could I mark that? Arc marks, right? You feel okay with that? So lots of ways to mark it, right? You can put the 55 and the 55, you put the big 110 with the arc marks, all good stuff. Cool. Now, we're still going to do 3 and 4, but I'm going to walk around and see how we do on it. Could you in your table do number 3? Draw angle 1 and angle 2 as adjacent complementary angles, right? Could you draw them as adjacent complementary angles? Do they touch or don't touch? What does complementary mean? Adjacent